So this is what MapReduce is. So this is kind of funny, but I kind of like this picture, so I put it here. So basically, let's say you want to create a sub. So what happens? What are the steps in creating a sub? You kind of, you know, do you kind of prepare all the stuff separately. You cut down different veggies, right? And then you put them together to make the sub. So this stage, the first stage, where different things can be done in parallel. So for example, let's say if there is only one person making a sub, what he'll do is first he'll perform this first step, and then he'll cut the cucumber, then he'll cut the capsicum, and all this stuff, right, in series. So this will be like in series, right? And finally he'll put together all these things, and he'll create the sub. But if let's say you have three persons, okay, and together they want to make it, what can happen is first person can perform these two operations, second person can perform these two operations, third person can perform these two operations, and this stuff can be done in parallel, right? So for example, let's say each one of these operations takes, let's say, 5 minutes. If one person was doing this job, he'll take first 30 minutes to just cut everything, and then probably let's say 5 minutes to put them all together. So it will take 35 minutes to make a sub. But if you have three persons doing the job, all three of them can perform these two operations in parallel, right? These operations in parallel, which means each person will be taking 10 minutes, right? So within 10 minutes, you have everything ready, and in next 5 minutes, you can put them all together. Any one of them can put all of them together. So in other words, you have your sub ready in 15 minutes. You have saved 20 minutes. So the stage of your processing where you can do things in parallel, okay, the stage of your processing where you can do things in parallel is called the map stage, okay. And then your map stage produces some intermediate output, okay, every map task. So you can consider all these six activities to be different map tasks, okay. Every map task produces some output. Reduce task will take output from every map task, it will combine the output together and produces the final output. Does that make sense at a high level, guys? Mappers work in parallel, okay. Once all the mappers are finished, then reducer starts, and your reducer takes the output of all the mappers and combines them and provides the final output, right? So now if you uh, revise that particular concept of yarn, where we said every app master will be launching its own tasks. What are these tasks, right? These are the tasks: maps and reduces. So for example, for this application, let's say if this is an application, you'll be launching 6 map tasks and 1 reduce task. So total there are 7 tasks that will be run for this application, right? Now this is your data. These are your data blocks which might be present on different data nodes. You'll be running a task on all of those data nodes. That task will produce an intermediate output, and these tasks will be called map tasks. Reduce task will take the output of all these map tasks. It will aggregate them or combine them together based on some logic, okay, and it will produce the final output. If I is saying I like the reference to food, that will help remember since everyone has to eat. That's correct, Eva. Even I like this example. So this kind of makes it, connect with the real life example, right? So at a high level, the message that I want to send across from this diagram is, in every activity, right? In every activity, or at least whatever problem you want to solve using MapReduce, the problem has to be of the nature that some part of the problem can be done in parallel, and then finally some part can be done uh, in one step, right? So whatever problem can be divided, can be put into this category where some part of the problem can be solved in parallel, that is a problem suited for MapReduce, right? So now, having talked about this, let me actually uh, give you a problem, okay? Again, a theoretical problem, and you guys have to tell me how that problem maps to the MapReduce paradigm, okay? So now let's say you have a lot of coins with you, okay? You have a lot of coins with you, let's say hundreds or thousands of coins with you, okay? Some coins are, let's say, 1 rupee coins, some coins are 2 rupee coins, some coins are 5 rupee coins. So basically you have coins of different denominations, okay? And the problem statement is you want to count, coins of every denomination. So you want to figure out, I have, let's say, 200 coins of 1 rupee each, I have 300 coins of 2 rupee each, I have 500 coins of, let's say, 5 rupee each, something like that, right? So that is your problem. How can you solve this problem if, let's say, you have 10 friends with you? So you have 10 friends, all of you are sitting together, you have a lot of coins lying there, and you want to quickly find out how many coins of every denomination you have. Okay, Rajesh is saying each will take a denomination to separate from the collection and then we'll count them. Okay. If I is saying everyone inputs their coin information in parallel. Yeah, that's more like it. So Rajesh, let me tell you a problem with your solution. So Rajesh is saying each one will take one denomination to separate from the collection and then we'll count them. So Rajesh, the problem with this is you will have to first go through all the data, or in other words all the coins, to first filter out coins of different denominations, right? So that will take a lot of time. So in other words, who will be doing that job? Who will, first find out, different coins of different denominations, and then so that they can be counted separately? So that is kind of a difficult job, right? Because you'll be kind of scanning all the coins first, putting 1 rupee coins on one side, 2 rupee coins on another side. So you would better just count them while you are doing that. So that is like one person doing the whole job. How can 10 people parallelly do it so that it can be done faster? Rajesh, I hope you understand the problem that I've just described with that solution. Yep. So guys, the see. Yep. So guys, see, simple solution is, let's say if you have your 10 people sitting together, whatever is the number of coins you are having, just blindly divide it into 10 parts. Blindly divide it into 10 parts. Okay, there is no need to look at how many, I mean, what are the 1 rupee coins, what are 2 rupee coins. Don't just bother about that. Just divide the input into 10 parts. Okay, everyone takes one part and starts counting coins of every denomination. So for example, let's say I am one of them. I got total 100 coins with me. I start counting these 100 coins. I start separating them. So for me, the whole problem is to solve the bigger problem at a smaller level, right? So for me, input data set is 100 coins only, and I want to solve the complete problem on 100 coins. So out of 100 coins that, let's say, I come up with, I have, you know 25 coins of 1 rupee, 30 coins of 2 rupees, and 45 coins of 5 rupee, right? So let me just try to write here. So I am Mohinder. My output is, I am saying, 1 rupee coins 25, 2 rupee coins 30, and 5 rupee coins are 45. So that is my output. Similarly, second person will have its output, right? 1 rupees some x, 2 rupees y, and 5 rupees z. So this will be the kind of output from every person, isn't it? And everyone is doing this in parallel. Now initially, let's say I had 1000 coins, right? 10 people did this in parallel. So in other words, if one person was working on 1000 coins, let's say he would have taken uh, uh, let's say 100 minutes. Okay, if 10 people are doing it in parallel, they can do it in 10 minutes, right? So this output gets generated in 10 minutes. Now all I need to do is, all someone needs to do is take this output from every friend, right, and just combine them. So for example, I have 10 such records, right? 10 such records where 10 people will be telling me how many 1 rupee coins they have. I just need to add them up. I get the final result. So this is what a mapper is doing, and that final aggregation will be what a reducer will be doing. Does that make sense, guys? Cool. All right. So now at a high level, at least we understand what kind of problems are solved using MapReduce. Can I assume that, guys? We understand what kind of problems can be solved using MapReduce? Good.